Okay, now today is going to be entirely review, okay? It is probably going to be very uncomfortable for you to be able to have to remember all this stuff again, but trust me, it will come back fast. So we're working on the transformation unit, and this 30-1, this is the first year that actually the transformation unit is a review slash carry on from the transformations you did last year, because the pure 30s before did not do transformations at all until grade 12. So hopefully we'll see that that worked out, teaching you some of it last year. So we're going to go right to page 78. And let's talk about this stuff. Okay. Now, if you have the function y equals f of x, that is like the skeleton function. We don't know what the function is, y equals f of x. But if you take y and replace it with y minus k, that describes a vertical translation. So y minus k equals f of x describes a vertical translation. Now, if you take the x and replace it with the x minus h, that is a horizontal translation. So y equals f x minus h is a horizontal translation. Okay? Now, using this form, because I don't like using the other one, because in the other one you have weird rules. So if, remember the k, if the k is positive, aka greater than 0, that means positive, right? Then the graph moves up. If k, the number after the negatives or the minus sign, is negative, aka less than 0, it goes down. If h, the number after the minus sign, is positive, then it goes up, right? And if h is less than 0, then we go left. Now remember, it is the number after the minus sign. So even if you remember back to last year, if it was y plus 3 equals f of x plus 2, remember I got you to change it to y minus negative 3 equals f of x minus negative 2? Because we want to look at the number after the minus sign. And if y plus 3, well, there's no minus sign. I can't do it number after the minus sign. How might, well, let's make it so we can use our rules. So this would mean 3 down and 2 left. Remember that? And to be more specific, we would say a vertical translation, 3 units down, and a horizontal translation, 2 units left. Is this sparking a few memories? Something's waking up in there? Yep.
So those two equations are the same?
Yes. Those are the same equations. Because plus 3 is the same thing as minus negative 3. Okay. So I'm going to be asking for a lot of help today because this is reviews. So I'm going to see who remembers what's going on. Now, if you had f of x, and you take x and replace it with x plus 2, we get y equals f of x plus 2. Now, the question is, in words, what does that mean? Okay, so I'll do the first one for you. This would be a, now I'm going to write it the way I like to know it, and that would be equals f of x minus negative 2. So that would be a horizontal translation 2 units left. Okay? We always say what it is, how far, and what direction, in that order. Yes? Yes, we'll get to that. I wanted to do the first one using full, because if I have students that I didn't teach last year, and if I start doing HT, VTs, they might not even know what I'm talking about. Okay? Now, if I'm replacing y with y minus 8, now remember, it's y equals f of x, right? If I take y and replace it with y minus 8, what is happening? Very good, yep. So a vertical translation, 8 units up. Okay, so remember, we want to get used to the wording again. It's what transformation, how far, and what direction. Okay? Okay, so now I don't want anybody calling out or anything. I'm going to start asking people to be able to give me A, the substitution, and B, what it means in words. Okay, so let's, y equals f of x is the original function. So what got changed or what got replaced, okay? So who am I going to start with? Whose lucky day is it today? Why don't I start with Victoria? What got replaced? So x got replaced with x minus 3. Okay, and what is that? No. How many units? Good. Okay, the next one. Kate. Okay, so what? Tell me what it would look like. Okay, so the replacement. No, what's the replacement, first of all? Okay, and in words? Okay. Regan. C. Okay, so in words? Perfect. Okay. Now, example 3 would be more like it's definitely a diploma question. They give you a point and they give you a transformation. Say, what would be the new point? Okay? So we don't need to do both of these. We'll just do B. Okay? Now, let's get the transformations into words and then we'll move the point. Okay, Landon? What happened? Okay, so why don't we rewrite the equation just so everyone can see what you're talking about. Okay, so the replacements. Well, give me the replacements first, and then we'll do words. Yeah. Okay. Okay, so if I had a graph and point 2, negative 3 was on it. So 2, negative 3 would be about there, right? Okay, so let's do the first one. If I was 5 units up, what point would I become? Much. No. 2, 2. Good. And then if I want 7 units right, that would become 9, 2. Now the diploma wouldn't give you an easy transformation like this, but it might be one with all the stretches and reflections and everything in it, and they'll just say, or they might even say, and what is the sum? Or, here, they'd love to do this for numerical response. What would be the sum of x plus y? And you would say 11. That would be your numerical response, right? Because 9 plus 2 is 11. So that's what the diploma likes to do with for numerical response. Okay? Nice job. Okay, let's do C. So if I had y equals f of x, what would a translation of m units right and p units down look like? Bennett. First of all, give me the replacements. Okay, so y turns to y plus p. Okay, what about, we got this one, units right, so what would be another replacement? No, just x. Okay, so what would the equation look like? No, y plus p, right? Or y equals f x minus m minus p, right? You could bring that p to the other side. Yes, that's... This wouldn't be a written response. This will be a multiple choice, most likely, but either form is acceptable. They won't have both of them as the answers. The diploma is not, mean that way. Okay, they're mean by hard questions, but not mean by being sneaky. Okay, let's just do B here. Okay, so if we have y plus 2 equals f of x plus 3. Now, in words, actually, I need replacement and words. What's happening? What's going to happen to this graph? Jessica? Give me replacements first. Okay, so now the words. So now you need to take this graph and move it 2 units down, 3 units left. Now that might seem a little, of a difficult test. So instead of doing that, take this point and move it 2 down, 3 left. And then take this point, then take this point, then take this point, then take this point, then connect the dots, right? So if I go down 2 over 3 on each point, down 2 over 3, down 2 over 3, down 2, or, and then down 2 over 1, 2, 3. Mm-hmm. Yeah, I see that right now, yeah. Okay, now, obviously, I'm hoping that if I have this shape, moving all those points should be the same thing as going down 2 over 3. Okay, now, again, if you're moving a shape, you should be surprised if it turns into a different shape. Okay? But some of you aren't surprised. That's the weird thing. Okay? Same thing when you do reflections, actually. They should not become a different shape. Okay, so, it's like if you move your couch, it shouldn't turn into a chair. Okay? I mean, some couches turn into a bed, but that's a whole different conversation. Okay? Now, the next thing is we're going to talk about mapping notation versus replacement notation. So we've been doing replacement notation the whole time. There's also what's called the mapping notation. Now, mapping notation is quite simply, if you come down and look at this, so this is what the mapping notation means. It'll have x comma y, then a arrow, and say x, take all your x's and add 3, and take all your y's and add 2. Now, do you know that when you take all your y's and add, or x's, sorry, and add 3, it actually moves it 3 right. And if you take all your y's and add 2, it actually goes up 2. But if you were making an equation and you wanted to do the same thing, you would have to do the exact opposite when you make your equation. If you want that thing to go right, you actually have to take x and replace with x minus 3. Okay, so mapping notation is taking the points and adding 3, where the replacement notation actually takes the formula and makes it do that move. Okay, so the best way to probably explain this, let's do an example. Okay, so state the coordinates of the new image after -3, 5 under the described mapping rule x, y, x minus 7, x plus 4, y plus 4. So that means take your x value, so I have -3, and I'm going to minus 7 to it. And I'm going to take, so what is my new point? -10. And it says take 5 and add 9 to it. And I will get, add 4. Where am I getting that? And I will get 9. I know I got that from somewhere. Okay. Okay, so the new point would actually be -10, 9. Now, if that point was on a graph, and I actually wanted to do the equation that would move that, then I'm going to have to do the translations differently. Now, I actually want to come up for, I wish they would have done the same one above. I want to do the same one above, x minus 7, comma, y plus 4. What would the equation actually look like if I did that mapping rule? Now, if I want to do a horizontal translation, 7 units left, what would be the substitution in the equation? X would go to what? X plus 7. And this says move up 4, right? That's what is in the mapping rule. So to get your equation to move up, so I want 4 units up. That means y would have to go to y minus 4. So my equation to be able to move -3, 5 to the same spot would be y minus 4 equals f of x plus 7. Or y equals f of x plus 7 plus 4. Okay, so mapping rule in many senses could almost be say it's opposite to the substitution rule. Okay, or the replacement notation. So we're doing 1 to 10 there. Okay, and let's go to next notes, lesson 2. Now, if you see, lesson 2 starts off with all the identical stuff that we just talked about, and these are some just redundant examples. So let's go here because we actually haven't done one where they have the before and after picture. It says write the equation. What is the equation of the new? Okay, so this is the before and this is the after. Okay, now this is the before equation, y equals absolute value x. Now, when you move an entire shape, it may not look as cut and dry because you're going to get all maybe confused about the shape. So move just one point that corresponds to the other point. So this point here corresponds to this point here. So then I know I'm doing this and then this. Okay, so now I want to come up with some replacements. Okay, so in words, first of all, we'll start there. In words, what is happening? Because what's in words is actually in the, exactly what's in the shape. So Isaac, what's happening? And then? Okay, now give me the replacements for that. Okay, now if this is the original equation right here, what would be the new one? Absolute value. Oh. No, we don't have the f of x because we actually have an equation this time. Okay, or okay, good job. And you don't have to guess on this, just graph it and it should look just like that. Okay, one more example. Okay, again, something common that could show up on a diploma. What horizontal translation would be applied to y equals square root x so that the translation image passes through 17.8? Now, you have to kind of do one of these to actually see how do they all work. And basically, they won't give you a vertical and a horizontal at the same time when you're finding this. So this one's giving a horizontal and A was giving a vertical. But the way you do this is, first of all, if it's a horizontal translation, I know that x must be being replaced with x minus h. Now, some people say, but right away you're already assuming that it's going right. No, I'm not. When I get my answer, if h is positive, then I know I'm going right. But if I get a negative h, it means I'm going left, right? So I'm not assuming that I'm going right by doing this. The answer will tell me right or left because it's the number after the minus sign. So now I'm actually going to do the replacement. Y equals square root x minus h. Now some people would look at this and go, yeah, that's awesome. Now we have 3 things we have to find. Before it was only 2. Okay? But we know that this point is on this new graph. So 8 equals square root 17 minus h. Okay? So now all I'm going to do is solve for it. So I can square both sides. So I'll square this side and then I'll square this side. And I will get 64 equals 17 minus h. Then I will subtract 17 to both sides. And I will get 47 equals negative h. Okay? That means I need to divide by -1 or multiply by -1, and I will get -47 equals h. Therefore, I know it's a horizontal translation, 47 units left. Okay? Now this is all review, so hopefully the homework goes smooth. Okay, so we're doing 1 to 8. And cut.